This is a question which was asked in GATE 2014 for 2 marks for mechanical ME paper. So basically what we need to do is we have to crash project duration to 9 days and see what is the total cost associated with that. Okay, now we have given the cost law for drawing the network with the predecessing activities, and the duration is also given. So let's start doing it. First of all, we need to make the we need to draw the network, so that then only we can find out the what are the critical what are the paths and what are the critical paths. So let's start. So this is P. P does not have any predecessor, and Q is having a predecessor P, and R is also having a predecessor P. So this will be, this is my R and this is my Q, and S is having predecessor R and merging, that is the last activity, so it has to be merged with Q. So P is 3, Q is 7, R is 4, and S is 5. So we have two parts, P, R, S will be 4 plus 3 plus 5 will be 12, and PQ, which will be 10. So this is the total project completion time. PRS is the critical path. Now, first of all, let's calculate what is the total cost if the no crashing is there. So zeroth case will be total cost will be zeroth case means no crashing. So 10,000 is the normal cost. Even though the individual costs were not given for activities, the total is given. So 10,000 is the total cost. Plus we know that there will be an overhead cost of 200 per day. So since we have 12 days, 12 days is the project completion time. So 12 into 200 will give you 2400 plus 10,000 will give you 12,400. So this is the total cost if there is no crashing. So now we think about so 12 days is there. So if I crash 1 day, it will be 11 days. If I crash 2 days, it will be 10 days. Then there are chances that this both this will be the critical path. Then we have to see what are the chances. So we cannot means even we reduce directly 3 days from this path. So still our total projection completion time will be 10 days, because we have another path which is having 10 days. This will be the critical path. So we can only do the 12 means 2 days crashing at the first go. Then we have to see what to do. Now first case, then we have to see 2 days we are going to crash. So which activity we will crash? So P is there with having 500 slope, and R is having the cost slope of 400, S is having the cost slope of 200. So 200 is the minimum, so we can crash S. So first thing we will do is crash S by 2 days. So every the duration is given in days. So we can do the thing. So the total cost will be this 12400. So that is the current cost now without crashing. Plus 200 will be for S, right? And for 2 days means 2 into 200. Now, if I reduce 2 days, if I crash 2 days, I am saving 2 days of the overhead. I'm saving 200 rupees per day as an overhead cost, right? Which I was having if it was 12 days. So I can reduce those amounts. So 2 into 200. This is the overhead cost. I'm for if it was 12 means 12 days, and now I am only having 10 days. So 2 days overhead cost I am saving. So it will be coming to be same, because it is cancelling each other. 200. This will be the same. So I'm not gaining or losing any money, but I'm still gaining 200 and 2 days. So I have crashed 2 days without losing any money. So next thing is I have to, now this will be 10, right? Now I have to so S will be 3. So I can only try now I am there is crash limit is not given. So I'm crashing that. I'm taking it as assumption that I can crash any amount is that is possible, since it is not given. So you can also take assumptions like that. The second case is I have to reduce 1 more day, then only my project completion time will be 9. So either it will be from this means both paths has to be reduced by 1 day. So which one will we select? for we know that for the initial this thing, S is the for the PRS path, S is the minimum one, so I can reduce 1 day from S. And for PQ path, so Q is the minimum one, which is having 100, and I can reduce Q by 1 day. So reduce crash S and Q by 1 day. Then our total cost will be this 12400 plus the cost of Q will be 100 plus the cost of S will be 200. And since we are saving 1 day, the overhead cost will be reduced by 200. So that will be 12500. So now our this thing is 9. So that's what it was asked. So if the project completion time is 9 days, if the duration is limited to 9 days, what will be the total cost? So this will be the cost. But there is another possibility that suppose P is a common activity for PRS and PQ. Suppose if I reduce P, how much it will be? How much increase in cost will come? 500 rupees, right? But it is a common thing. So we have only we have to see the case P by 1 day. Then it will be total cost will be 12400 plus 500 minus 200. It will be 12700. Anyhow, it is greater than this, so we will not take this case. But this has to be checked because we have chosen Q and S to be crashed based on the ranks, right? So this is given the higher priority because it is giving you the less cost. So cost is given the priority. But if take the case if P was 250, still you will take Q and S because that will give you from among this path means PRS path. So still S is the candidate to be reduced, and for this also Q will be the candidate to reduce. Then it will be we will end up with the same amount. But if I crash P, then the additional time this thing will be for this case will be 300. It was added, and this will be if it was 250, it was only 250, so that you are saving 50 rupees, so that you will end up with 12450. Then this will be the least one, so that we have to go for this option. But anyhow, this case it is not happening. But since there is a suppose if it's a common factor which can be reduced, you have to check that also and keep that also into account and do the calculation and see that which is the minimum. That is how you do the thing. So for the current case, the answer will be 12500, and if you get it right, you will get 2 marks. Now let's discuss some questions which was asked in the previous GATE question papers for ME and PI from the PERT analysis. So this is a question. It was saying that there are 6 activities A to F. The duration is also given. The network has 3 parts: A, B, C, D, and E, F. All the activities can be crashed with the same crash cost per day. So crash cost per day, the cost slope will be the same. The number of activities need to be crashed to reduce the project by 1 day. So for that, so let's at least there are 3 parts it was saying. So better to draw those parts and see. But it means from the without the figure also it can be done, but let's do it for more clarity. So first part is A to B. So this is my A, and this is B. We know that path means it has to connect from start to end. So this is one path, this is the start and this is the end. So similarly, C and D. So C and D. So this is the end. Similarly for E and F. Just understand the question and saying that there are three parts, say A, B, C, D, E, F. So one could get confused, but don't get confused. Just draw that thing, whatever we know, whatever we have learned. So these are the parts. So A, B means A is 7, B is 5, C, D is 6, E, F is 8, 4, and the durations will be for AB, for the AB path, it will be 12, 7 plus 5, CD is 6 plus 6, 12, and EF, it will be 8 plus 4 is 12. So all have same duration, and that is all are critical path. So if I want to reduce the project duration, so now it is 12. If it has to be reduced by 1 day, so what should I do? I should reduce one activity from each. So the minimum, any of them, since the cost per day is the same, means that cost slope is same, which gives us the freedom to reduce any of these activities. So from this path, either A or B has to be reduced. From this path, one has to be reduced, because if I reduce only one of the paths, what will happen? So this will be 11, but still our project duration will be 12. That we have already learned about those things. So we know that if I want to reduce by 1 day, this has to be 11, this has to be 11, and this has to be 11. So at least one of the each activity has to be one of the activity from each path has to be reduced. So we have to reduce at least 3 activities. So this will be the answer to the question. So this question was asked in 2006 GATE for 2 marks. So we need to find the standard deviation of the critical path. So first of all, we need to work out the network. Then you get the critical path. Then you get the standard deviation for that critical path. So let's draw the network first. So just given A does not have any predecessor, so we can start from A. So this is A, then B is starting from A, C is also from A. Now D is from B, E has to be started just after the completion of B and C. So we can draw E from here, and also but we have to give the precedence relationship that B has to be also be completed for starting D, E. So and F has to be from E, D and E. So this is also a merging event, and this E also should be started from a merging event. So I can draw a dummy here. So this is my dummy, and this is my E, and from there F starts. The duration is 30. B is 40. C is 60. D 25. E 45. And F 20. Now list down all the possible paths. So A, C, E, F, A, B, D, F, A, B, E, F. So there is a this is the path A, B, E, F. Since the dummy is there, we don't have to include that dummy in this when you calculate this one. So and let's find out the length of each path. So 30 plus 60, 90 plus 45, 135 plus 20, 155. 30 plus 40, 70 plus 25 plus 20. So 115. And there is 30 plus 40, 70, 105, 135. 105, 135. So the highest is 125. This is our critical path. So A, C, E, F. This is our critical path. Now we need to find out what is the standard deviation. So for that standard deviation, you have the formula sigma equal to root of variance. So for the critical path, so which will be just root of. So A, what is the variance is 25 plus C 81 plus for E it is 36 and F it is 9. So total it will be coming to be 25 plus 81 106 136 151. So this is the answer. So from the choices you can select this answer. So one thing you have to mind is that when it was asking for a particular path, you must the variance can be added together. Not each. Don't take the root from each and add them to get the standard deviation. That's not the way. Means if you know the statistics, the variance can be added. Then you have to take the variance has to be added, and then take the root to get the standard deviation. So that's how you solve this problem. Another simple question, just asking the formula. So optimistic time is TO, pessimistic time is TP, most likely time is TL. Then what should be the TE, expected time? So expected time is nothing but optimistic time plus pessimistic time plus 4 times most likely time divided by 6. So from this choice, A is the answer. TO plus 4 times TL plus TP divided by 6. So for this question, the network is given. So all the optimistic, most likely, and pessimistic times are also given. So what it was asked is the standard deviation of the critical path. For that, we need to find the critical path first, and also for that we have to find the TE, expected time. So let's start doing. So expected time is nothing but TE equal to TP plus TO plus 4 times TM divided by 6. So let's find out TE. So for this one, 4 times 2, 8. 8 plus 1, 9 plus 3, 12. 12 divided by 6, it will be 2. This one, 24 plus 10 plus 2 divided by 6. So it will be 36, 6. Then this will be 5. This will be 7. 4, 5, 6, and 3. So this is the expected time, and based on this expected time only, we can find out the total means length of the path or the critical path. So let's find out the critical path. Now, what are the possible what are the possible paths? So 1, 3, 5, 6, 7. Now 1, 2, 5, 6, 7. Now 1, 4, 7. I think these are the 3 paths. Only 3 paths are there. So 1 to 3. 1 to 3 is 6. Then 3 to 5. 3 to 5 it is 4. 5 to 6 it is 5. Then 6 to 7 it is 3. So the total will be 9 plus 9, 18. So for this one, 1 to 2, 2. 2 to 5, 7. then 5 plus 3 will give you 17. The last one, 5, 1 to 4, 5, and 1 to 4 to 7, 4 to 7 is 6, 12, 11. So 18 is the project duration, and this is our critical path. Now we have to find out the standard deviation. For that, we have to find out the variance first. So variance is nothing but TP minus TO divided by 6. So with this formula, we can find out the whole square. Don't forget that. Okay. So 3 minus 1 is 2. 2 divided by 6, which is 1 by 3. 1 by 3 whole square is 1 by 9. We don't need to list out all. Only for the critical path we will list down. So 3 is a critical path. So which is 7 minus 5, 2 divided by 6, 1 by 3, 1 by 9. Then 5 to 6. 5 to 6 is 6 minus 4 is 2. 2 oh no, which is the critical path? 1, 3 to 5, right? Oh, 3 to 5 is there. So this one. So what is this? 6 minus 2, 4. 4 by 6 means 2 by 3. 2 by 3 whole square means 4 by 9. Then 5 to 6. 5 to 6 it is 1 by 2 by 3, 2 by 6, 1 by 3, 1 by 9. Now 6 to 7, 4 minus 2, 2, 2 by 6, 1 by 3, 1 by 9. This is not there. So these are the 4 variance values. Now for calculating the standard deviation is nothing but sigma variance, which will be equal to root of 1 by 9 plus 4 by 9 plus 1 by 9 plus 1 by 9 will be 7 by 9 under root. Okay, but this is coming to be 0.8888. This has to be the answer, but actually 7 by 9 we will get is root of 0.77. 0.77 it will be there, but that is so this will be the one thing. Maybe they have wrongly given this question. Maybe they are asking about the variance only. If it was variance, then you can simply write it this thing. But in this thing, it was asked standard deviation. If it is standard deviation, it is 0.88. Also, I want to tell you one wrong answer, which is D. Why this? When did this D comes is, suppose you are calculating the for sigma is equal to root of variance, and then you find each sigma from the variance, and then if you add it up, then what will happen is this 1 by 3 plus means if you take the root 1 by 3 plus 2 by 3 plus 1 by 3 plus 1 by 3, so it will be 5 by 3. So that will give you this 1.66. That's not how it has to be done. So the variance has to be added, then you have to take the root to get the standard deviation. This is also a simple and straightforward question, but in the PERT chart, the activity distribution is, we assume that it is beta distribution. Don't confuse it with normal distribution. We use normal distribution, standard normal chart for calculating the probability. It's not about the activity. It's just to calculate the what is the probability that our activities will complete within certain time. For that only we use the normal charts or normal curves. But the PERT is purely beta distribution.